All right. So we're gonna if you didn't get your test, just grab them afterwards. I do have them. The grades are also in Alex, so you can keep track of your grades there. The Alex grades are close to being correct. They're not exactly correct, but they're close. So all the topics will open up. Actually, I'll probably open up the Monday before Thanksgiving. I'll open up everything. So you guys go back and do all the topics, any topics you want. And they'll be due the Tuesday before the final. Okay. So remember that if you've got 90s on your tests, and as long as you have 80% of the topics done, you're exempt from the final. So as soon as you hit that 80%, you're fine. If you don't hit that 80% until the Tuesday before the final, I'll just let you know then. That's fine. So, because that Tuesday before the final, we don't have class. You have other tests or whatever that day. So, all right. We're going to continue more proofs. These are the next set of identities that you're going to need to know. We're going to do some more a little harder ones, continuing with what we talked about on Tuesday. I always sometimes forget what day it is. It's Tuesday. So we're going to do those, and then we'll go into some of the odd and evens and the sum and difference proofs after that. Yes. Pretty much. You're going to use them all. So yeah, it's unfortunately they don't get easier. Some proofs are easier than others. It just depends on the problem, how many steps and stuff you're going to have to do in them. So, all right, let's start looking at some. Let's do this one. So let's look at one that's similar to what we did. I'll put those back up there when we get to a problem that specifically needs them. So, all right, let's look at this one. So this one gets rid of the addition, right? So somehow we kind of have to get rid of that addition. So which methods do we have to get rid of that addition? What rules work with the addition stuff? So we have to use some kind of a Pythagorean rule, right? That's the only way to get rid of our addition and subtraction. Really, that's all we have. So here's the Pythagorean identities. I don't have one with secant and cosecant. Yeah, let's try. Let's see what happens. So if I change this, this is 1 over. We got 1 over cosine squared x plus 1 over sine squared x. So we're using reciprocal rules for those. Okay. Well, now I have a fraction. That's not helpful. I need one. I would somehow I'm gonna have to put these fractions together because I don't have fractions on the other side. So how do I put the fractions together?
Same binom.
I need a common denominator, right? So my common denominator in this case is going to be cosine squared sine squared. So I could change. So basically, if I multiply, my bottom's going to be cosine squared x sine squared x. So this side's going to have to be sine squared x, and this side's going to have to be cosine squared x, right? So that's an algebra step. Okay. I still have addition. I haven't gotten rid of my addition yet, but do I have something that might be able to help me get rid of my addition now? Yeah, I now have the sine squared x and cosine squared x, right? Which is what? That's 1. So I now have 1 over cosine squared x sine squared x. So it's Pythagorean. Okay. I don't have division, so I somehow have to get rid of my division now. But if I reciprocal, I can split it and then do the reciprocal on both of them, right?
What's that last letter? Is that
it's a P. It's a P. Pythagorean. So if I flipped them, I would get secant squared x and cosecant squared x, and that would be reciprocal. And that's what I wanted. So you were right. Again, like sometimes switching to sines and cosines is helpful. Even if it doesn't look like it was at the very first step. So, and that's where a lot of like the manipulation skills that you learned in algebra really come into play with this stuff. It's like being able to figure out a problem. It's like, okay, I've got this. What can I do to put things together? Common denominators with fractions comes up quite a bit. So, like those little things. And remembering you can't then go, oh, I can just cancel that and that. No, you can't cancel with addition through addition, as much as some people would like to try. All right, let's try another one. All right, your turn. Alex gets the step problem done in 3 steps. I don't expect you to get it done in 3 steps. You're probably gonna add a few more in there to manipulate the problem a little bit. That's not something most people are going to. Can't think of anything. Besides it goes on. Fortunately, it takes a little messier at the beginning. You can give everything to that. Oh, no, it's conjugate effects. Yeah, I know. Yeah.
Should we be using the new one, these?
Right. Okay, so somehow you've got to change that to that. You've got so think about it. We don't have secants. They're all cosine trying to do this. So trying to change the cosine. So use reciprocals to try to change the sine to cosine, and then maybe things will work out. I'm just looking to see what people are actually trying. Yes. Most people.
I switched that.
Okay, but you still have a plus. You can't get rid of your plus that way. Then I'm not, don't use the rules on it. Secant is 1 over That's fine. It's still 1 over because your position is with the fraction. You're welcome. All right. Most people either got it or totally netly stuck on like the first step. All right. Go to sines and cosines. So this becomes 1 over cosine of x plus cosine of x. 1 over cosine of x minus cosine of x. Okay. Yes. No. You can't. So the only time you can cancel things on tops and bottoms of a fraction or in the numerator is if it's with multiplication. So like 2x over 2y, that's x over y, because I can cancel out the 2's. 2 plus x over 2 plus y does not equal x over y. I can't do that part. Doesn't matter. Because if you think about it, if x was, let's say x was 5 and y was 8, right? So 2x would be 10, this would be 16. 10 over 16 is still 5 over 8, right? If this was 5, so that'd be 7 over 10. 7 over 10 is not 5 over 8. Okay? No, even if you put parentheses on it, wouldn't make change much. So that's the thing, is you can only cancel things through multiplication. All right. So I know a lot of people want to try to do that. Whenever you see something on top of bottom, you try to cancel out. If it's not multiplication, you cannot do that. So that will cause a ton of your issues if you try to do something like that. All right. So we've got this. Now, think back to the last problem we did. When I had a fraction, what did I try to do with that fraction? Yeah, I want to get my denominator the same, so there's one fraction and not two. because when there's one thing, then I do have some multiplication things that I can start to work things out. So if I took this, my denominator is cosine, right? I want to let's see if I can get rid of my denominator. So I'm going to multiply everything by cosine. So I'm going to multiply the top by cosine. That wasn't a C, that was parenthesis. And the bottom by cosine. Can I do that? Yes, because as long as I do the same thing to the top and the bottom of a fraction, it comes out to be the same thing, right? It's the opposite of what the rule I just told you. Okay, so what's cosine times 1 over cosine of x? That's just 1, right? Because cosine divided by cosine is 1. So that's 1. Actually, I'll put it next to it. That's 1. What's cosine times cosine of x? Cosine squared x. Hey, now it's starting to look like that. All right, now let's do the bottom. Cosine times 1 over cosine of x. That's 1. Cosine times cosine of x. Cosine of x or cosine squared x. Okay. So my top's right. My bottom's not. So what did I do? What can I use in the bottom to change it to sine squared of x? Just Pythagorean. So I end up getting 1 plus cosine squared x over sine squared x. So that's Pythagorean. I used reciprocal there. And I used algebra there. Three steps. Okay. So far, the ones that we've looked at, these go back to that. Let's change them to sines and cosines and figure things out. But if you notice, pretty much every problem we do is different. So they're not all going to flow the same way. All right. One more of these types, and then we'll get into some of the new rules. Those are like puzzles, like because that's basically what they are. It's a puzzle.
Right.
One of the things that I said originally was don't work with both sides. I'm not changing that. So don't don't go that direction. But we can use the other side to start getting an idea of what we need to do. Okay. So the tangents kind of switch, but we're not quite sure how that's going to switch. But this and this are very similar, except for their different signs, right? What do we know about the different signs? They're what? What are they called? Conjugate pairs, or the difference of squares. So when you multiply things by its conjugate pair, we can get squares and no longer have the middle term. So if we take the tangent of x and multiply it by secant of x minus 1, and we take the bottom, the top's going to stay the same. Like I can't do anything with the top. But the bottom now becomes secant squared x minus 1. And I now have that on top.
If you didn't have the other side, how would you go?
So, and this thing, you're either, well, for the topics that we're doing, you're always going to have the other side. If you didn't have the other side in other situations where you need to manipulate the problem, you're not necessarily getting to a specific thing, but you have an idea of what you want it to be. Like, I want a Pythagorean, so I know I'm going to be able to get rid of it, or that's going to get rid of something to make it multiplication or division, those things. So it's like, you don't necessarily have exactly what the final thing is going to look like, but you have an idea of what you need it to do to solve the problem that you're working on. So in this situation, it's not really getting rid of the subtraction, but it's moving it to the top, which means I can split up fractions, which might make my life easier when I'm doing integration and stuff. Where on the bottom, I can't split up a fraction. But if the addition and subtraction is on the top, I can split it into two different things. So that might be helpful. So I'll show you that in a minute after I finish this problem. So right now we're now at tangent of x, secant of x minus 1 over secant squared x minus 1. What's the secant squared x minus 1 become? Tangent squared x. So that becomes tangent squared x. So that's Pythagorean stuff. So now I have tangent x secant x minus 1 over tangent squared x. And now what can I do to those two tangents? I have 2 on the bottom, in essence I have 1 on the top, so I can cancel one of them out. And this becomes secant x minus 1 over just tangent x, and that's an algebra step again. So what I was saying, like this I can't split up, but this side I could actually go to secant x over tangent of x minus 1 over tangent of x. I can now split that fraction up into pieces, which I couldn't over here. I can then say, okay, well, that's secant of x is 1 over cosine of x, and this is sine over cosine of x. So that right there becomes 1 over sine of x, which is cosecant of x. And that becomes cotangent of x. So I could actually change that original problem down into a simple single function on both sides. So it's like that's the, when you're looking at it that way. Now, this problem right here is going to be very hard to do integration and differentiation with, because you're going to have to use quotient rules set up. Where this, I can find the integral of that and that separately, which might make my life a lot easier. So that's where the manipulation of the problems go in, where you've got this, and I really want to get to something like this. I just don't know. I like, you now have to figure out the steps there, because you know I don't want division. I want something simple.
If those two are correct,
Yeah, this equals that.
can you get from secant of x minus 1 tangent of x to
Yeah,
secant of x minus
yeah, I just did that. That's what I did here.
Yeah, I started doing the tangent of x, secant of x plus 1, and I did like the reciprocal rule.
Yeah. So it's like you can get there. This all this is equal. Okay. So, and that's the thing. It's like, if without giving you the final step of where you're stopping, you could keep going forever. Like I wouldn't know where you'd want, like what you'd want to stop at. That's why they have to give you that piece. Where in a typical situation, you know kind of where you want to get to the point. It's like, okay, I've got to a point now that I can do this problem, so now we can use it. So, okay. That's why. All right, so let's look at some even and odd functions. All right, so a couple things actually before I do these, because I've heard a few things said and I've seen a few things written, and I want to make sure people realize they are two different things. Cosine of that does not equal that. Okay? It does equal that. Okay? Those are two different things. Okay? So just be careful how you're writing it and what it means. So like that means whatever the cosine of x is, I'm squaring that. It's not the angle squared first. Okay? Why I'm saying that is because I don't want people to look at this and assume it equals that. Okay? Just because you can't just take the signs out. Doesn't work quite like that. Same thing with that exponent. It doesn't, you can't just put it in with the term inside. Those don't work that way. Okay. So the odd and even rules, which I had you write down at the beginning. So there's these 6 rules over here. So if you remember from what we were doing before, we were doing the transformations, whatever's in front of the x, the angle inside, I'm doing to the x value. So if there's a negative sign there, that basically in essence flips it over the y-axis. So using the y-axis as the symmetry and flipping it over that. If we look at, let me look at my graphing calculator. So if we look at sine of x, over the y-axis, what do you notice happens to it? If you flip it right over the y-axis, it's not going to flip exactly on top of each other, right? It flips over and then goes down. So that's where it's the negative sign of the sign of negative x you have to have the negative sign out in front. So we have to flip things over to get it to become the same type of function. So sine of negative x is the same thing as negative sine of x. Those are equal to each other. Now, if we looked at cosine, if you look at this as symmetrical across the y-axis, both sides, if you folded this in half, what would end up happening to them? They'd be exactly the same thing. And that's why cosine of negative x is the same as cosine of x. Okay? So, and we can do the same thing with the rest of the functions too, and see how they flip over on top of each other. So these are those even and odd functions. And remember, back to your polynomial functions that you probably did in intermediate algebra, stuff like that, they were talking about even and odd polynomials. If they were all even exponents, they were even. It's because they were symmetrical across the y-axis. If they had all odd exponents, they were odd functions, they were symmetrical across that y equals x line. They basically flip both directions. That's what these are. That's why they're called odd and even functions. So cosine and secant are your even functions. They're symmetrical across the y-axis. The other ones are all odd functions. They're reciprocal. They're symmetrical across the y equals x axis, the y equals x line, where they both flip. Why do we need these? Well, what happens, the nice thing is the goal is to keep the angle as pure as possible. Okay, so we want to be able to, if we looked at what I did over here, we have a negative sign inside, we kind of want to get it out. Okay, because I don't want to have to deal with that. So how can I get it out? That's what those rules state. Okay, cosine, I can't just pull it out, but the other ones I can, because they're odd functions. Okay, so that's what those functions allowed us to do. It's allowed us to clean up the angle, so those angles are same, and then I can work with the function alone. Right. Let's look at a problem that involves them. So you'll notice in this one, the key is if all the values are the same, if all the angles are the same, I can work with it. If the angles aren't all the same, I can't put things together. So remember, one of the things we looked at was like if it was sine of 2x and cosine of 2x, I can use those and put those together because they're just 2x. If one was sine of 3x and was kind of cosine of 2x, I can't put those together because they're not the same. Same thing in this situation. I've got negative x's and I've got just x's. So there's no way for me to put those together. So let's make them all x's. And then I can put things, then I can start working out that piece. So the first thing we want to do to this is let's take these and change them so they are just the value of x. So secant of negative x using the odd and even rules is what? That's secant of x. Sine of negative x is negative sine of x. Well, not yet. Let's notice I put parentheses around it on purpose. What's tangent of negative x? Huh? Is negative tangent of x. All right. So now I have secant of x minus sine of x tangent of x. Because I have 3 negative signs that are all multiplied together. That was why I didn't change the sign and then have, because they're all that's all multiplication right there. Okay. The other reason was, and why I put them in parentheses, is because somebody, I guarantee, would have done this and no longer had multiplication and now had subtraction. Okay. Yeah. So it's like those little things can cause problems. So when you're changing things in signs, parentheses are your friend. They'll prevent mistakes like that. Okay. All right. So we used our odd even rules for those. All right. So we still need to get this to be cosine somehow. So what do we want to try next? Quotient rule? What's the quotient rule going to help do? Okay. So I have secant of x minus sine of x over cosine of x. So quotient. Okay. So we're in the process of changing everything to sines and cosines, right? All right. So we kind of want to do the same thing with the secant. Let's change that one over. Remember, in Alex, you cannot do these as the same step because they are 2 different sets of rules. That would be my reciprocal rule. But now if we look at this, we have cosine on the bottom, right, of both fractions, and I have the secant or the sine squared x there. So I can put this all together. And that's just an algebra step. Okay. What was it? Yep. Now I can use Pythagorean on the top there. This becomes cosine squared x over cosine x. So that's Pythagorean. And then that just becomes cosine of x, and that's an algebra step. So we used our even, odd, and even rules, and then we went back to the fallback. Let's change everything to sines and cosines. Okay. Yeah, just remember you can't do the quotient reciprocal rule at the same time because they're actually 2 different rules. It's really easy to fall into the trap of doing because on your paper you're going to do that. And like I said, on your test, if you just put quotient reciprocal rule and same, that's fine. But Alex doesn't like that. So if you hit it and it goes, that's not a valid step. That's probably why, because you did 2 of those things at the same time. So really, the only thing that the next set of rules does is it just adds another rule that you could possibly use to break things down, which means it adds even more things that you have to possibly look at to start your problem and to simplify it down. However, the odd and even rules are the nice thing about the odd and even rules is they're very specific in what they're used for. They are only used when you see a negative sign inside of your angle situation. Okay, so if you don't have a negative sign inside your angle, you're probably not using odds and even rules. Yes.
Would it be possible to do this with the nuclear before?
No, because the angles aren't all the same. So we want to change this from a negative x to a positive x. The only way to do that is with the odd and even rules.
But if that was a negative sign,
Then I could have done the other rules and it would have been fine. It probably would. It might not have come out to be the exact same answer just because of the way the sign switched. But actually, no, actually, in this case, it would have worked out fine because the sign didn't actually change here. So yeah, if that was a negative x, I wouldn't have had to do the odd and even. And actually, that's the same thing we're going to look at with the sum and difference rules. We're going to use those when the angles are not the same, but I need to find out a way to make them the same. So that's where the addition of the sum and difference rules come into play. All right. Okay, let's try one more. Let me pull up one more of those before I go on to the sum and difference rules. All right, try this one. All right, what do we want to start with? Yeah, let's do our odd and even, get rid of that piece. I know where you're getting the one. So cosecant negative x is going to be negative cosecant of x. Sine of negative x is going to be negative. So I already have a negative sign there. There's nothing else. So I'm going to change this to positive sine of x. Okay. So that's the odd even rule. All right. Yeah. Yeah. Let's just put everything with sines and cosines. So if I change this over, this is 1 over sine of x, negative 1 plus sine of x. Okay. What's next? Yeah. Okay, so we're gonna do common denominator, right? All right, so I'm gonna get my common denominator to sine of x. So minus 1 plus sine squared x all over sine of x. So that's algebra. Now, this up here is kind of like the Pythagorean identity, right? But the signs are different. So if I pull out the sign, let me just do it this way. If I pull out the sign, I would have 1 minus sine squared of x, right? And now that is cosine squared x. So now I have minus cosine squared x over sine of x. And that's Pythagorean. So what's the last? So I'm going to add, so if I split this up, right? If I split the top up, that's my negative cosine of x, correct? And this is, that's cotangent of x.
That's so.
So negative cosine of x, cotangent of x. And that's the cosine. All right. Let's look at the sum and difference rules. All right. So remember what I was talking about. We can't do things that have different angles. Okay. So we could, since these are just numbers, we could just use a calculator to get the answer. However, mathematics existed well before calculators did. All right. And the majority of problems did not fall into the nice little unit circle problems that we have. So not 30, 60, the 30, 60, 90, those type of problems. So they needed to come up with a way to be able to find the values of any angles without a calculator. And they kind of wanted to find out as close to an accurate value as possible for those. So the sum and difference formulas actually allow that to happen. So if we look at this problem that's right here, I can't figure out the cosine of 27 on the unit circle. I can't figure out the cosine of 18 on the unit circle. However, if we look at our rules over here, my sum and difference rules, I have cosine, cosine minus sine, sine, which is this one right here. So that means that this equals cosine of A plus B. So A is 27 degrees and B is 18 degrees. So that is the same thing as saying cosine of 27 plus 18. What's 27 plus 18? Cosine of 45. And what's the, using the unit circle, what's the cosine of 45? Square root of 2 over 2. And that's the answer.
We're going to follow that.
Yeah, they have a few types. It's more to make sure that you understand the rules. And I go back because it's nice to look at this because this is the reason why these rules exist. We have computers and stuff that can do a lot of these calculations now and get us our values, and it'd be fine. We can get them out to 100 decimal places if we wanted to, so we can get as accurate as you need. However, a lot of rules that we have in math today came from before that case. And what they did was they literally had books of tables. So like most of your logarithm rules that you probably learned in intermediate algebra and college algebra, like that you can take the log of x times the log or plus the log of y is the same as the log of x times y and things like that. It was because they wanted a way to break down everything into prime numbers, and they had a table of values for the prime numbers. They could do that, and they can find out the log of any value. Same concept here. This way they can find the exact values of any angles. And it's the same thing we're going to look at when we do the half angle formulas and the double angle formulas. If I take 45 and I cut it in half, okay, now I can find 27.5 degrees, not just 45 degrees. And I have a formula to be able to figure that out using ones that I already know. Okay. So there's 3 topics, or there might be, I think there's 2 or 3. That literally just work on this. So all you're gonna, yeah.
For that, do you not care about the signs?
The sign actually it's positive in this case. It's on the first quadrant.
The second half doesn't matter.
The second half gives you the first half. The reason it's minus is because there's a minus right there.
Yeah, but you don't have to do anything with the sign of 27, the sign of 18.
Oh, I got what you're saying. I don't have to because it actually is part of this whole thing. This whole thing right here equals just that. Okay, so I don't have to worry about doing each piece. I didn't just do this part. I did that whole thing by doing that. Okay. Let's look at one more of those before I do the other type of problem that they give you with this one.
Or you can use the circle again for this test.
I probably won't have one like this on the test. I'm probably going to have most of this test is going to be proofs. All right. So the goal with this is to figure out which rule we're going to use. And whenever you're looking at these, the nice thing about tangent is there's only two. And they only have tangents in them. So that kind of makes your life a little bit simpler. So I know I'm going to use one of these two down here. Look at your signs. Okay. Because that's what changes in the two of them. So in this case, I have a minus and a plus. So I'm using tangent of A minus B. So in this case, I have tangent of, and that's A, and that's B. So 167 minus 137 is the tangent of 30, which is square root of 3 over 3, if I remember right.
Hold on, wait.
It's less than 1 because 45 is 1. Square root of 3 over 3 is less than 1. And then the other one is square root of 3. So tangent only ends up being one of three things. It's square root of 3 over 3, 1, or square root of 3. Or 0 and undefined. But so that's literally all you're going to look at when you're doing this type of problem, is trying to figure out that piece there. Okay. The other type of problem that they have for this topic is this one. So they want to figure out, let me copy this over. So they're looking for cosine of A plus B. So they're looking for that. So I need to know cosine, I need to know cosine and sine of A and B. So we've got, let's look at the A's first. So we've got tangent of A is 3/4, right? Which two letters does tangent give you on the values? Tangent is what over what? Sine over cosine, which is y over x. So that's y and that's x. I also need to find what? I need to find r. So Pythagorean theorem, 3 squared plus 4 squared, r is going to be what? It's 5. So I know r is 5. It tells me this is in the third quadrant. So what does that tell me about x and y? They're negative. So y is -3 and x is -4. All right, so sine of A is what? 3/5. And the only way it's y, just y, is if it's the unit on the unit circle. That means r is 1. So since r is a value, you have to put that. So that's -3/5. And cosine of A is -4/5. So I know cosine of B is 5 over 13. And it's in quadrant 1. So find me x, y, and r. Mm-mm. What's cosine? Cosine is x over r, right? So x is 5, r is 13. So y is going to be what? Well, I will tell you a lot of times with this topic, they tend to use the Pythagorean triples. The 3, 4, 5, 5, 12, 13, those tend to come up quite often in this topic. So
What's that?
Pythagorean triples are what ones that solve the Pythagorean theorem that are all whole integers. So like a 3, 4, 5 triangle, that's Pythagorean triple, because 3 squared plus 4 squared equals 5 squared. 5, 12, 13 is another Pythagorean triple. So there's a bunch of them. Yeah.
Cosine.
Because you still have to have an angle. Cosine can't equal something. Cosine of an angle. Cosine's a function. So you always have to have those letters, the letter there. So now we can figure out, we got cosine of b, we just need sine of b. And sine of b is 12 over 13.
I'm a little confused how you got the r equals 5. I know so why do you do the Pythagorean theorem for tangent of A?
Because we're looking for, remember, it's a triangle.
Yeah.
So we've got the x and the y. We need to find the hypotenuse. Say, we actually did this, you did the same thing to find the 12 down here. You've got the x and the hypotenuse, you need to find the y. Whenever you have two of the three on the right triangle, you need to use the Pythagorean to find the third one. So cosine of AB, so if we now can go back and do this, cosine of A plus B is cosine of A, which is negative 4/5, cosine of B, which is 5/13, minus sine of A, which is negative 3/5, and sine of B, which is 12/13. So I've got negative 20 over 65 plus 36 over 65. So my final answer for this problem is 16 over 65. Notice in this one, it didn't matter what the angles were. It's just an arbitrary angle. Yeah.
Why is it tangent A? They just choose they wanted tangent A?
Yeah. Oh, no, they just chose it. Those will change for every problem. It's like they have to give you enough. They have to give you one of the trig functions for A, one of the trig functions for B. It doesn't matter which ones they give you, and they have to tell you the quadrant that they're in, because that helps you figure out the signs. If they don't tell you the quadrant, you can't figure out the signs. You'd assume it's in quadrant 1 at that point. And as long as they give you one of the trig functions, they give you two of the three parts of a right triangle, so you can use Pythagorean theorem to find the third one. So, but yeah, it doesn't make a difference which ones they give you.
Did you solve it if this didn't give you quadrant?
You would assume it's quadrant 1. Yeah, if they don't give you a quadrant, you assume quadrant 1. And this topic, they'll always give you a quadrant 1. So. All right, let's do some proofs. Now that we've played with them enough.
With the whole thing.
And you're still not having fun. Like, come on, what's wrong? I bring all my toys and you don't like to have fun. What's wrong? All right. just like we were looking at the odds and evens, these proofs are going to be very specific, and you're going to notice that, okay, I have to use sum and difference rules. Okay. They're going to have an addition or something inside of parentheses. If they don't, then you don't have to use the sum and difference rules. So they're going to be very obvious. Okay, I need to use this rule to do something with it.
Where did it come from?
Old people doing math before computers and calculators and cell phones and TV. All right, so actually, let's pull back up I'll pull back over the rules so I have them on the screen. All right, so sine of x plus y. So the first thing we're going to do is get rid of the sum and difference problems. Let's break them up so we have the pieces. So sine of x plus y, we're using that first rule. So this becomes sine of x cosine of y plus cosine of x sine of y.
Oh, that's how you do it.
And that was just that. Now let's do that. Minus, the minus one is sine of x cosine of y minus cosine of x sine of y. You'll notice that the two rules for the sines, they're exactly the same. It's just the minus sign between them changes. The cosines, they're exactly the same except for the sign between them changes. They're just opposite of what the original sign is.
Where did that make
Which one? This one?
one? Yeah,
The minus sign right there.
but there's still.
So black, red. There's still a minus sign in between. I haven't dealt with that part yet. I literally was just changing them to using the sum and difference rules. Now we can get rid of and change our signs and look what we got. So I've got sine of x cosine of y plus cosine of x sine of y minus sine of x cosine of y plus cosine of x sine of y. This one's actually really easy. We literally have one more step to go. Because that and that are the exact same thing. One's plus, one's minus. They cancel out. And all you're left with is 2 cosine x sine y, which is what we wanted. So that's all algebra. So we used the sum and difference formula once, and then did a bunch of algebra to simplify it down. Okay. What's different about this one? It's tangent. It has pi, which is an actual value, right? That's going to come into play. So treat it like A and B. But then when you have something you can solve it.
Factor out tangent.
No.
But I can't do tangent, factor out tangent.
No. Tangent's a function, not a value. Just split it up. Use that rule. So as I said, the sum and difference ones, just like the odds and evens, are going to be very obvious that you have to use. They might have a bunch like we did in the last one, but they're going to be very obvious. Because none of the other rules work when the two things inside are not the same. So we have to get them to be the same before we can do anything else. So A is pi and B is x. So I have tangent of pi minus tan x over 1 minus tan pi tan x. What's tangent of pi? It's 0. So 0 minus tan x over 1 minus 0 tan x is just negative tan x. So sum difference, algebra. Unit circle. Tangent of pi is sine of pi over cosine of pi. Sine of pi is 0. And cosine of pi is negative 1 at that point. So it's 0. As long as cosine wasn't 0, it works. So, oh yeah. Yeah, you could easily just type in tangent of pi in your calculator. As long as your calculator's in radians, you'll get the right answer. So
I still don't remember.
I those are ones that I've memorized because you use so darn much. All right, find this one. It's the Y's. All right, so which rule are we going to use? So we have to use both of them in this case. So we have, what is it, cosine? Sine. Sine of pi over 6, and then cosine of x, plus switch cosine. Cosine of pi over 6, sine of x,
Let's say you messed it up, got the right answer.
I guess it's possible, plus sine of pi over 6, cosine of x, minus cosine of pi over 6, sine of x. So nice thing is those cancel out. So I have 2 sine of pi over 6 cosine of x. So it's sine of pi over 6, 1/2. So 2 times 1/2 times cosine of x is cosine of x. Oh, and I hit the wrong button. There we go. Come on. So will all the stuff get combined? Yeah. But odd and even rules and sum and difference rules are very obvious. And actually, even the half angle formulas and stuff that we're going to be looking at, they're very obvious on when you would have to use them. Okay. So it's not like they just pop out of nowhere. So it's not like you're going to be going through a proof and all of a sudden have to do the odd and even or the odd and even rule and stuff like that, because the other rules, the angles don't change. So these rules allow us to change those angles. Okay. And they're only used when the angles aren't the same. So like if the cosine of x at the end was pi over 6 minus x, you wouldn't have to use the sum and difference rules at all. You would use the other rules. And this one wouldn't have worked.
Why do those cancel out?
Because one's positive, one's negative.
You just find the term.
Yeah. They're the same thing.
Yeah.
So same thing we did back on this one when you did them. We had the sine of x cosine y, and then we had minus sine of x y cosine y. Those canceled out, so we didn't have to worry about those.
I don't know how. I had the sine and cosine, so I got 1/2 cosine plus 1/2 cosine. It is one cosine.
Well, that's fine. You would have had 1/2 cosine here plus 1/2 cosine here. So if you had done them all out, you would have ended up getting 1/2 cosine of x plus square root of 3 over 2 sine of x minus, or sorry, plus 1/2 cosine of x minus square root of 3 over 2 sine of x. Same thing would have happened. Those two would have canceled out, and it would have combined to be cosine of x. So same thing would have happened.
But it's wrong though.
No. No, they're both fine. Remember, the thing with proofs is it doesn't matter how you get to the answer. As long as your step, like as long as the math you are doing is correct, it's fine. The math, either one of those maths are correct. I just simplified it before I did the actual angles, where this one, you did the angles first and then simplified it. So, and this one, you had to figure out what the cosine of pi over 6 was. I did. That's the only difference. It's like it doesn't make a difference which way you do it. Either one of those on the test would have gotten you full credit for that problem because everything you did was mathematically correct. So, all right. I will see you on Tuesday. I will try not to make Halloween so scary.
Is Halloween next Tuesday?
Yeah.
Oh, shit.
Just say the subject is scary enough. But
If you didn't get your test, come get me. Come see me last name and your previous test Tuesday. Last name. Right on top. Last name. Don't forget, you have extra time, so you can take time to do this.
oh yeah, that's
You-
not the problem. It's remembering how to do it.
Okay. I'm like, just think, you do have that option.
But it looks like
Was it?
yeah, I did study up on those
Oh.
topics. It looks like
Okay, it just didn't click. There you go. Oh, just leave it. He'll come back. If no, I'll put it over here before I leave.
they got this one wrong. Yeah.
So this one, that's fine. The problem is you're looking for x. So you should have set that up as sine of x equals 14 over
Oh.
17.
Oh,
You forgot the inverse of it. Yeah.
Yeah, I think that was the problem. I forgot some of the small details.
Huh? No, let me say. You did want to find the region that was cleaned out for the blade. Your mistake wasn't that. Your mistake was you forgot pi. So your formula was wrong. So it was the 125 over pi, which is fine. That gives you the radians. And then you needed to find the full thing and then subtract off that piece. That was what you had to do. So you were really were looking for that. See you on Tuesday. Yep. So 0 times tangent of x is? No. 0 times anything is 0. So that's gone. So the bottom is 1. 0, and then that's just 0 minus that. So that's just negative 10x.
Oh, okay.
I have. I don't know what I'm teaching next semester yet, though. So last semester I taught Calc 1 last semester I taught Calc 1 and stats. The semester before that, I taught Calc 2. So it's like I taught them all. So I'm not sure what I'm teaching yet.